My students keep asking me the same question. Professor, what's the difference between AI, machine learning, LLMs, agents, agentic AI? Are they the same thing? Is ChatGPT an agent? Is Claude agentic? And honestly, I don't blame them for being confused. Even developers who have been in the industry for years are tossing these terms around without really understanding them. Agentic AI, AI agents, generative AI, predictive AI, classification AI, neural networks, transformers, diffusion models, it sounds like alphabet soup. And the worst part? When you try to look it up, you get conflicting answers depending on which blog post or LinkedIn influencer you're reading. Someone says an agent is just a fancy chatbot. Someone else says agentic AI is the future of everything. It's noise, and it's confusing my students more than it's helping them. So today, I'm going to break this down once and for all. Not with complex math. Not with dense research papers that take a PhD to understand. But with the simplest analogies I could find. The human body, a construction team, and even a music band. By the end of this video, you will fully understand the many kinds of AI. And more importantly, you'll be able to spot when someone knows what they're talking about versus when they're just throwing buzzwords to sound smart. I'm an IT professor. And this is the stuff your syllabus doesn't cover, but absolutely should. Let's start with the foundation. Everything in modern AI begins with the brain, which is exactly what artificial neural networks are inspired by. Here's the simple version. Human brains have neurons. AI brains have nodes. Our neurons communicate with electrical signals. Some are stronger, some are weaker. AI nodes communicate with mathematical signals. Some are smaller, some are bigger. They pass numeric values from one node to the next in layers, each layer learning to recognize more complex patterns. The first layer might detect edges in an image. The next layer identifies shapes. The layer after that recognizes objects. Each layer builds on the one before it, creating a hierarchy of understanding. That's it. That's the core idea of how neural networks learn. So a neural network is the brain structure of AI. But just like human brains, there are different kinds of brain structures. Some are more artistic. Others are more mechanical. Some excel at recognizing patterns in images. Others are better at guessing the next word in a sequence. In AI, we call these brain structures architectures. And each architecture has a dominant organ, a specialty. Understanding which architecture does what is the first step to understanding the AI landscape. Let me show you what I mean. First, CNNs, or convolutional neural networks. These are eye-dominant. They excel at computer vision, recognizing objects, faces, patterns and images. When your phone unlocks with facial recognition, that's a CNN at work. When a self-driving car detects a pedestrian, that's a CNN. When a medical AI spots a tumor in an X-ray, that's also a CNN. Think of CNNs as the AI's eyes. They process visual information by scanning an image in small chunks, detecting patterns that human eyes would miss. Next, transformers. This is the big one. ChatGPT, Gemini, Grok, Claude, they're all built on transformer architecture. These are tongue-dominant because we mostly use them for language tasks. Communication, understanding, generating text. That's also why some transformers are called LLMs or large language models. They process and generate language by understanding context. The key innovation of transformers is something called attention. Instead of processing words one by one, transformers look at the entire sentence at once and figure out which words matter most to each other. That's why they can understand nuance, sarcasm, and complex instructions in ways earlier AI models couldn't. Finally, diffusion models. These are hand-dominant. They paint, draw, compose music, and physically produce the products of our imagination. Midjourney, DALL-E, Stable Diffusion, these are all diffusion models. They work by starting with pure noise, random static, and gradually removing that noise step by step until a clear image emerges that matches your description. When you type a cat wearing a hat in the style of Van Gogh and get an image back, a diffusion model started with visual static and carved your cat out of it. But here's what I want my students to understand. Even though we're dealing with eyes, tongue, or hands, these are not standalone organs. Each of them is a function of a brain. Deep inside all these architectures are neural networks. Think of them as eyes and brain, tongue and brain, and hands and brain. But here's the catch. Having the ability to see, speak, or create is not the same as having a purpose. You can have the most powerful brain in the world, but if nobody tells it what to do, nothing happens. What turns capability into action? Intent. Deciding what to do, in what order, and towards what goal. In AI, this goal-driven coordination is what we call an agent. Let me give you a concrete example. Imagine you want to paint a picture of an elf. First, you imagine it in your brain. You envision a facial focus, bright colors, thick black outlines. Only then do you start painting. Now translate that to AI. You have an agent made of 3 organs. A brain that understands the task and envisions what the image should look like. A tongue that communicates what the brain imagined. And hands that execute what the brain and tongue planned. In technical terms, you have a language model working with a diffusion model to accomplish a task. These models live in a single AI agent that receives text and turns it into an image. The key word here is orchestrates. An agent doesn't just run one model. It runs multiple models in sequence, passing information from one to another, to achieve a result that no single model could produce on its own. Now here's the million-dollar question. When does an AI agent become what people call agentic AI? This is where most people get confused, so listen carefully. An AI agent is like an employee. You give it a task, and it gets it done. Single cycle. Task in, result out. No reflection. No iteration. Just execute and return. Agentic AI is like a manager. You give it a full-blown project, and it oversees it from start to finish. It can delegate to specialized employees, or it can accomplish everything on its own. And here's the key difference: it works in cycles. Agentic AI is defined by behavior over time in an autonomous loop. Think, act, observe. Repeat as needed. Each cycle improves on the previous one until the goal is met. Let me give you a real example you've probably used. When you're coding with Claude or Cursor in agent mode, it doesn't just throw a piece of code at you. It understands the task, writes an initial version, runs it, observes the output or error, then improves the code. Think, act, observe, loop until the feature works correctly. That's agentic behavior at a single agent level. But agentic AI goes even further. It covers multiple agents working as a coordinated system toward the same goal. Imagine asking an AI to plan a 5-day vacation in Tokyo for under $3,000. Behind the scenes, you don't get one answer. Instead, one agent looks for flights. Another searches for hotels. Another researches activities and attractions. And an additional agent manages the budget in real time. The flight agent books a ticket. The budget agent recalculates. If there's room, the activities agent adds something better. The entire vacation schedule updates in cycles without you getting involved even once. That's agentic AI. It's not a single answer. It's a system that manages outcomes over time. Now let's talk about what AI produces. This is another way to categorize AI, and it's the one most people get wrong. Generative AI produces something new that didn't exist before. Text, images, videos, audio inspired by the instructions you provide. When ChatGPT writes an essay, that's generative. When Midjourney paints a picture, that's generative. When Suno creates a song from a text prompt, that's generative. It creates. Predictive AI forecasts what will probably happen next. It doesn't create anything new. It calculates probabilities and finds patterns in historical data. Given house prices in your neighborhood from 1970 to today, what will your house be worth next year? That's predictive. Given stock market data, will a particular stock go up or down? Predictive. Given weather patterns, will it rain tomorrow? Predictive. It forecasts. Classification AI decides what category something belongs to. Is this email spam or not? Is this animal a cat, a dog, or a chicken? Is this credit card transaction fraudulent or legitimate? Is this MRI scan showing a tumor? Classification doesn't create or predict, it sorts and identifies. It's the digital equivalent of a quality control inspector on an assembly line. Now here's what I want my students to really understand. These categories aren't mutually exclusive. In fact, a modern AI system is often all three at once. An AI agent processing a customer service request might use classification to understand the category of the complaint, prediction to estimate how urgent it is, and generation to compose a personalized response. The categories describe what it does, not what it is. Knowing this distinction helps you understand what any AI tool you encounter is actually capable of. Let me tie all of this together with one big picture. If generative AI is an artist that creates something beautiful out of nothing, then predictive AI is an oracle that studies the past to see the future. And classification AI is a detective that examines evidence and identifies patterns. If an AI agent is an employee who gets a specific task done and reports back, then Agentic AI is a manager who oversees the entire project, delegates tasks, checks progress, and keeps iterating until the outcome is right. And if neural networks are the brain itself, the fundamental computing structure, then CNNs are the eyes that process visual information, transformers are the tongue that handles language and communication, and diffusion models are the hands that physically create and produce. Now here's why all of this actually matters for your career. The biggest tech companies in the world are already moving in this direction. NVIDIA CEO Jensen Huang keeps saying that developers are shifting from manual coding to building alongside AI. Companies aren't hiring for how many programming languages you've memorized. They're hiring for how well you understand systems. They want people who know which AI tool to use for which problem. People who can design agentic workflows that automate business processes. People who understand the layers well enough to know when the AI is wrong. That's the competitive advantage in 2026. So here's what I want you to take away from this video. Not just a list of definitions to memorize for an interview. A mental framework. A map of the AI landscape that helps you navigate the hype and focus on what actually moves the needle. When you hear someone talk about AI agents, you now know exactly what they mean. When a vendor pitches you Agentic AI, you know what questions to ask. When you read about a new model architecture, you know where it fits in the big picture. That's the stuff your syllabus doesn't cover. That's real AI literacy. I'm an IT professor. And I want you to understand this stuff deeply enough that you can spot when someone's selling you buzzwords versus when they're sharing real knowledge that can actually help you build and grow. Subscribe for the stuff your syllabus doesn't cover. Drop a comment. I want to know which of these AI concepts was the clearest for you after watching this video. Was it the CNN versus transformer distinction? The agent versus agentic difference? Or the generative versus predictive breakdown? Let me know. I read every single comment.